Okay, welcome to the final exam review video number 1. I have no idea how many I'm going to make, so we're just going to start off with one, see where we go. Now, I'm going to make this review video, it's going to be different because I'm going to go ahead and give you the answer first, and then I'm going to show you how I got the answer. Alright, so let's go and get started. Question number 1, having to deal with credit cards. Alright, so what should the credit card check digit be? Now, I start with the first number and I skip every other one. Alright, so notice what I did. Started with the first one, skipped every other one, and I'm going to add all that together. And when I do that, this is going to be step 1. I end up getting 21, and you have to double it because credit card multiplied by 2. You're going to get 42. Okay? I need that number, so hold off on that. The next part is all the numbers that I chosen for step 1, I look to see which one is greater than 4. In other words, which one is 5 and higher. So that 4, nope, it's got to be greater than 4. Oh, there we go, there's one. Just going to mark that right there. Oh, there's another one, 9. So for step 2, the answer is 2 because there's 2 numbers that are greater than 4. Now, the last step is taking every other number that you skipped, which was this 0, this 1, this 6, this 9, add it all up. So step 3, add all those numbers up that I skipped originally, that's 29. So off to the side, 42 plus 2 plus 29. I get a grand total of 73. Now, in order to make a credit card valid, this total has got to be something that ends in a 0. Well, we don't know what our last term is, so that means in order for this to be a valid credit card, it has to be 7. Because if that was 7, we'd add 7 to it. There you go. It'd be 80. All right? Next one. What would make the check digit, or what should the check digit be to make the UPC valid? Same or similar to the credit card. First off, starting with your first number and skipping every other one. Add all that up and then times it by 3. So when we times it by, add it all up for step 1, it ends up being 13. And we times that by 3, we get 39. All right, so put that off to the side. Now, the next part is just adding all the ones that you skipped. So all the ones that not that one, that one. All the ones that I skipped, add them up. And you don't have to multiply them by 3 or anything. You don't have to multiply many, just add them all up. There we go. So off to the side, 39 plus 10. I get a grand total of 49. But notice, what would that check digit have to be? Well, it would have to be 1 because, again, UPC's got to, when you total everything, it's got to end with 0. All right? Now, there were 10 sentences with a total of 160 words in a paragraph. There were a total of 275 syllables. All right? Now, this is a formula problem. All right? So, here's my formula. Fog index. So the number of words, hopefully you have the review right in front of you. So the number of words was 160. The number of sentences was 10. The number of complex words was 10. And the number of words again was 60. So the way you set this up is 0.4 bracket parenthesis 160 over 10 close parenthesis plus 100 parenthesis 10 over 160 close parenthesis close bracket. You are going to multiply everything in the bracket first. Okay? Then when you do that, it's going to be 0.4 times the number times 0.4 times that number, and you're going to get your answer. And the answer ends up being 8.9. So basically, this paragraph is written basically at a 9th grade level. All right. What is the Flesch-Kincaid grade level index? All right. Again, take your information, and now it's doing the Flesch-Kincaid. The number of words was 160. The number of sentences was 10. The number of syllables was 275. And the number of words again was 160. So that's going to look like 0.39, 160 over 10, close parenthesis, plus 11.8, 275 over 160, close parenthesis, minus 1559. Now, you can just throw all that into your calculator and just press enter. Use parentheses, everything correct, and you would get 10.9. All right, next question. For the fan cost index, how much does one ticket cost at a Rockets game? Well, remember, it's a family of four. 4 tickets must be purchased. 4 Cokes will be purchased. The adults will drink the beers. Everybody's got to eat a hot dog. 1 car is going to be taken. The kids have got to have the programs. And lastly, the kids have got to buy ball caps. All right, so the way I set this up, 4 times x is 4x, plus 4 times 4.5 is 18, plus 2 times 7 is 14, plus 16, plus 15, plus 2 times 0 is 0, plus 2 times 12 is 24. That gives me 175. Combine like terms, solve for x. You get 22. Now, it says if 4,500 families attend the Houston Rockets game, how much money would the team make? Well, the FCI, this represents how much money a family of 4 will spend at a game. So that equals 1 family. How many will 4,500 families? Just multiply 175 times 4,500. Let me put some, label that correctly. There you go. And it'll be $787,500. All right, next question. Determine how many home runs a player had. Singles, doubles, triples, home runs. Now, another formula question. Oh, here it is. Notice singles times 1s, doubles times 2, triples times 3, home runs times 4. All right, and so here's our information. So our singles, 250. Our doubles is 80. Our triples, it says home runs, but we're looking for triples. My bad, sorry. Triples will be X. Home runs is 65. The at-bats is 1453. And the slugging percentage is .718. All right, so I'm going to plug all this in to this formula to solve for X. Now, here's how it looks. Let's see if I can do this all in one shot. I can, good. All right, so 1 times 250 is 250, plus 2 times 80 is 160, 3 times x plus 3x, 4 times 65, I want to say is 130, all over 1453. Now see how it has slugging average right here in the front? I always like to put it in the back. Maybe it's just an old math person habit there. Now, to make this easier, we got to get rid of the denominator. So take your denominator, take what it's equal to, and you'll multiply them together because denominator means divide. So 250 plus 160 plus 3x plus 130 is equal to 1,123. All right? You are going to combine like terms and then solve for x. All right? Now, it says how many bases did the player have? All right? Now, we found out that there was 124 triples, which was amazing. I don't think that could ever happen. All right? But anyway, we'll just go with that. All right? So, 124. So, how many bases did the player have? Here's what you do. Singles, a player will touch first base 250 times. Now, with the double, that means you're getting on second base. So every single double, you actually touch 2 bases. So that is 160. Triples, it'd be 3 times 124. And I just don't have that off the top of my head. And then home runs, every time you hit a home run, you touch 4 bases. So 4 times 65. Wow, I said that was 130. That should have been 260. I knew something looked weird there. 260. Add all these numbers up. That'll give you how many bases you have. So 1,123. That's it. All right, let's keep going. Find the quarterback ranking or rating of the Manning brothers. Peyton Manning. All right. Let's see if I can put all this in one. Okay, I can. Now, here's our formula. Right here. Here's our stats. So, you are going to figure out all of this and plug it into the equation. All right, so for example, the percent of completions per attempt. completions per attempt. Completions was 198. The attempts was 331. So 198 divided by 331. 198 divided by 331. That gives me 0.598. Now, see this right here? It means completions in percentage. So that means I need to take this and I need to convert it back to a percentage. So that's 59.8%. I'm just going to round that to 60%. So that'll be 60. This is the only formula in the entire, I would say, year where you actually keep the percentage a percentage and do not convert it to a decimal. All right, next. It is, let's see, what else? Our touchdown passes per attempt. So touchdowns was 9. The attempts was 331. So off to the side here, 9 divided by 331. So 9 divided by 331. That gives me 0.027. All right. Now, again, you were converting that back to a percentage. And that's 2.7%. Percent of interceptions. Interceptions was 17. Uh-oh. Lights turned off. There we go. Lights turned off. All right, interceptions, 17. 17 divided by 331. So 17 divided by 331. 0.051%. So converting that to a percentage, that's 5.1%. Now, of course, you're filling all this stuff in. 2.7, 5.1. And the reason I kept this going is because I want to do this very last one. The average yards per attempt. Yards, you can see it right there, 2,249, divided by 331. That gave me we'll say 6.8. Now, notice this is not a percentage. These are just an average. So that means do not take 6.8 and move the decimal over. Don't do that. 6.8. 6.8. So in your calculator, 25 plus 10 times 60 plus 40 times 2.7 minus 5.1. I'm sorry, minus 50 times 5.1 plus 50 times 6.8. Press enter. You're going to get a big number and then divide it by 12. Your answer is 67.9 and then 93.6 for Eli Manning. Same thing, different numbers. All right. Now, question number 7 is a repeat. We already had this problem, so it accidentally got pasted again, so I'm sorry about that. But that'll be the end of video number 1. Hope you learned something. Let me know if you have any questions. Thank you.